Today we have another SMT 2021 problem. Suppose f of x is equal to the square root of x squared minus 102x plus 2018. We let a and b be the smallest integer values of the function that can be derived from integer inputs. Given that a is less than b, find a and b. So basically what we have here, let's just say this is y. So make this y is equal to the square root of x squared minus 102x plus 2018. Now we square both sides to get y squared, to get rid of the square root. So y squared is equal to x squared minus 102x plus 2018. Basically, what the question is asking, we want to, there's two input values that satisfy this equation. We want to find those two input values. We see that this is a quadratic equation, so this here is this has to be a 2ab according to formulas. So we can rewrite this as 2 times 51x. We know that this is an AB term, and term here is already used up, 1. So there's another square here, which is 51 squared. So we rewrite the equation. We get a 51, y squared. This is x squared minus 102x plus 51 squared plus 2018 from here, and then you subtract the 51 squared. So now this is already an equation. We can factor it out. Y squared is equal to x minus 51 squared plus 2018 minus 51 squared. So now we can actually solve this because we have the time to, and then just do stuff. So y squared is equal to x minus 51 squared plus 2018 minus 51 squared, or 2,601. So now we solve this. So y squared is equal to x minus 51 squared minus, 2018 minus 2,601. It's minus because it has to be negative. This is just 583. Now we just swap these two values to get here a plus b and a plus b times a minus b equation. So 583 is equal to x minus 51 squared minus y squared. So 583, this is really equal to x minus 51 plus y times x minus 51 minus y. Now here's the real solving part. So first thing we do, we assume that this is greater than this. Now 583 can only be factored out 2 times. 583 and 1153. Now we just put these in 2 case scenarios to see if they're correct. The first case scenario is where x minus 51 plus y is 583 in this case, where x minus 51 minus y is 1. So we just assume that this is 583 because it's probably greater than this since it's adding a y instead of subtracting it. It's basically. Now what we do here in this first case, we subtract x minus 51 plus y minus x minus 51 minus y. This is 583 minus 1, or 582. These all cancel out. You're left with 2y is equal to 582, and y is equal to 291. So we have our first input value that works. Now, let's solve for our second case. Our second case is where x minus 51 plus y, this is equal to 53, since it has to be greater. X minus 51 minus y, it's 11. We do the same thing, we subtract x minus 51 plus y minus x minus 51 minus y. Once again, these all cancel out. 53 minus 11 is 42. 2y is equal to 42. So y is 21. So we have found our a and b values. Earlier in the problem, we were given that b is greater than a. So this is our b and this is our a, where these two numbers are like the smallest integer input values that can actually be inputted into the equation and work.